Cool. Yeah, thanks a lot for having me. Thanks, Cayman, for making the recommendation. It's helpful to have someone say things like 3074 might be more helpful than 1559 from people other than me, because then I just sound like a shill. So I appreciate having other people do the shilling for me sometimes. Let me do this presentation mode. Okay, so I want to talk about EIP-3074, and you might have heard some things about it. And there's a lot of nuance for this EIP, and so hopefully we can try and come out of this with a better understanding of what this actually does. And at a high level, I just want to say that EIP-3074 is trying to allow EOAs to operate like smart contract wallets. And there's a lot to unpack in what that necessarily means. And that's really what this talk is going to be about, is what does it mean for an EOA to sort of act like a smart contract wallet? And to actually just motivate why we want EOAs to act like smart contract wallets, we can look at some of the UX problems that anyone who's ever interacted with Ethereum has probably noticed. A major one is that a separate transaction is needed for token approvals. I think this is the most egregious thing in the Ethereum ecosystem, and it hurts me every time I have to interact with some protocol and I have to split two transactions just to begin using tokens. There's a more general problem with this where actions tend to correlate with transactions one-to-one. You don't see as many transactions doing multiple things when it's just an end user interacting with the blockchain. A lot of times it's very sequential. They do one transaction to do one thing, they do another transaction to do another thing, and they're incurring a lot of complexity and understanding what's happening, and they're incurring extra costs by paying for these initial transaction fees that are charged for the transaction. And this is frustrating to deal with. There's not great defenses if you end up losing your keys. If you are using a hardware wallet or using a MetaMask account and you lose the keys, there's nothing that can be done. If you don't have a backup of your keys or your mnemonic anywhere, you're out of luck. And this may be okay for the place that we're in today, but I wouldn't want to ask my parents or my grandparents to try and store their financial lives in something that could be lost in a boating accident. It's also impossible to perform actions without Ether. And as Ethereum, the platform, continues to grow, more and more people will begin to receive stable coins and NFTs as their first interactions with the platform. And if they need to wait till they are able to deposit some Ether into their accounts just to do things with those assets that they're receiving, I think that that's a big issue. And the root of all of these problems is sort of around how contracts are developed in Ethereum. And pretty much all contracts today authenticate actions via message.sender. And you can look at just the transfer function in ERC20 contract, and you can sort of see that this message.sender thing is how the transfer is figuring out whose balance is going to be deducted. And you can see it right there. The balance of the person who sent this transaction or is sending this call is having the value deducted from them and it's added to the destination. And pretty much all contracts on Ethereum use this as an authentication mechanism to determine who the owner of an asset is. And the problem with that is that if you're an end user and you have a private key and a wallet and you're trying to interact with the chain, there's only one time during your transaction where the message.sender is actually equal to your address. And if you sort of look at this kind of call flow where the EOA sends a transaction to contract A is able to authenticate the user because message.sender is equal to the user's address. And so they're able to do whatever the action the user asked to do. As you try to chain things together, you lose that property. Contract A calls contract B. Now message.sender in the contract B context is A's address. B calls C. Message.sender is B's address in the C context. And so there's no way to use the protocols mechanisms for authenticating things. And you just have to try to find different solutions to this problem. So there's a couple of solutions that people have kind of come up with, and meta transactions is something that for a long time we thought was the solution to these UX problems. And if you're not familiar with meta transactions or you've forgotten, this is sort of an example. This is the permit extension to ERC20s. and it allows you to post a signature on chain that says, I am going to approve this account to spend some of my tokens. And this this function will recover the address that signed the message, and it will make sure that that address is the same one that is calling, that this permit function is calling as holder, and it will update the allowance of that holder and the spender that's passed in. And so it's not relying on this message.sender ID, and that's what we're looking for. We're looking to not rely on message.sender. But meta transactions have been talked about since at least 2017, and they're not really materializing as a strong solution. And I think the biggest problem with meta transactions is they require explicit support in the target contract. You actually have to write code in your contract that says, recover the address from the signature and verify that this is a proper action, or you specifically say, I will trust any call that comes from this contract because they will recover the signature. And so there's no way to actually have meta transaction support across every contract on Ethereum, even contracts that were deployed before meta transactions gained traction. And I think this is a negative cycle because there's not enough contracts that support meta transactions, and so contracts don't necessarily deploy with meta transaction support, and tooling may not have great meta transaction support because there's not so many contracts. And it's sort of this like negative reinforcing cycle. The other solution is smart contract wallets, and smart contract wallets absolutely solve these problems, but there's a very high cost barrier to entry to deploy a smart contract wallet. And I think, there's things that smart contract wallets are going to be able to do that EIP-3074 can't do. But when you're comparing the difference between something that's free, which EIP-3074 allows you to solve these problems for free, versus something that may cost something on the order of $10 to $100 to get started, then that's a hard trade-off for a lot of people who want to onboard users. And I think smart contracts will always have a place. You can't have things like multi-sig wallets with 3074. These are things that can only be done with smart contract wallets. And so I don't think they're necessarily going away, but I don't think that they are the general purpose solution to these UX problems. So this EIP that Sam Wilson wrote back in the end of 2020 does actually solve these problems for free. And we've iterated on them over the last 6 months or so, and this is kind of the core of the EIP. It's providing these new opcodes that create this sort of primitive that allow you to arbitrarily set the message.sender. And so this first opcode auth takes a signature and it takes a commit hash or a commit, and the commit is a hash of the action that you wish to perform. That opcode is very similar to EC recover. It will return the address that signed the message, the auth message, and it will set a new context variable to the recovered address. And this context variable is then used whenever AUTHCALL is invoked. And whenever AUTHCALL is invoked, instead of setting message.sender equal to the contract that used the AUTHCALL opcode, it's set as the authorized address. And so these create a really powerful primitive that you can use to develop very arbitrary flows around how to send transactions and batch things together and allow EOAs to act as smart contract wallets. And so we can sort of look at this high level flow just in a really simplistic model first, and then we'll look at a more detailed model of how everything flows together. But at a very high level, what happens is a user signs a message, the contract verifies the message, and then the message is parsed into actions and executed. And this is very similar to meta transactions. I think that you can think of, if you have a good understanding of EIP-30, or if you have a good understanding of meta transactions, you can really just replace the part of meta transactions where the EC recover happens with 3074, and you get all the same benefits and can do all the same cool things. But if you're not as familiar, we'll just say you can sign messages to do things like approve DAI and trade for ETH. If ETH drops below 1,000, then buy ETH. And you have recovery mechanisms like if my nonce isn't updated for 3 years, then allow some arbitrary address to send transactions on my behalf. And these are things that you can sign in some message format, and you can send it on chain. And this is where the 3074 primitives come in. And so this verification portion is done by this auth opcode. It takes the signature that the user created over the message and the commit, which is basically the hash of the message, and it computes obviously the address that signed it. And it sets the authorized context variable. And then that message is parsed into actions, because the first thing is doing two actions. It's approving DAI and it's trading for ETH. So those are two different things. So that message has to be parsed into those actions. And then each of those actions are executed with an auth call. And the auth call is using the authorized address context variable. And so now whenever it hits the DAI contract or hits the Uniswap contract, it looks like it's coming from that user rather than the contract that called auth call. And the contract that called auth call is a really important contract in the 3074 world. I think for meta transactions, they're generally called like bouncer contracts. We call them invoker contracts because they're the contracts that invoke the EIP-3074 opcodes. And the invoker contracts are really important because the invoker contracts enforce the rules that are encoded into the commit. And this is kind of the really confusing part of 3074. A lot of the things in blockchains are built so it's very strong security guarantees. You know, in the Ethereum protocol, if you submit a transaction and the nonce is one greater than your current transaction, that's going to be valid. With 3074, you can have things like nonces and balances and targets that you wish your calls to go to, but it's up to the invoker to actually enforce that those things happen. You could submit a transaction with a hash of applesauce, and it could send all of your money to the zero address. There's nothing that's tying the commit that you're making to what actually happens on chain. It's up to the implementation of the smart contract, the invoker contract, to do that. And I think that's okay, that we rely on the implementations of smart contracts all the time. If you use a Gnosis safe, you rely on the fact that the Gnosis safe is implemented correctly, and DevOps 199 can't come in and steal your funds. So there's a lot of things about this idea of signing messages, and so this is what the message format actually looks like. We're calling it this auth message format, since the auth opcode is the thing that's sort of building this and parsing it and verifying the address that signs over it. And so there's three elements of it. The first is a type byte. This is just to avoid collisions with other types of transactions and things like the 712 message format. Then you have the invoker address, and this is a critical part because the invoker is the thing that's enforcing the rules. And so you don't want your message to just be replayed by any invoker. It might be possible to have a malicious invoker that disregards what your commit is and just does something arbitrary, like send tokens from you to an adversary. So it's important that you're signing over the invoker, because it's like you're saying that you choose this invoker and you trust that invoker to do the things. It's like saying, I trust MetaMask to not send my private key over the internet to someone. It's very similar in that sense. And then you have the commit, which is the hash of the action. And you can think of like a really simplistic commit as just one message call that's may have a nonce and a to and a gas and a call data, and the invoker would process those values and check to see, is that nonce valid? Does the user have enough balance to pay for that much gas? And if so, then go ahead and send this call data to this target address. And then you can do more complicated things. You could have multiple calls in one commit, and you can have it in some serialized format or some tree format. It doesn't matter, as long as it can be turned into some 32-byte value. And then the invoker contract will just loop through all these actions and call out to the contracts that you specify with the data that you specified and do those things. So now we can actually look at how the whole flow works overall. And so there's basically two ways to start a 3074 interaction. The first way we call self-sponsoring. And this is where you are the person who sends the transaction on chain. You're the person who's paying for the gas of the transaction. And so in that case, you send your transaction directly to the invoker. 3074 was really built in mind with having a strong in protocol primitive that allowed for sponsored transactions, things where you have people who will pay for the gas for your transaction and maybe be paid back in a token of sorts. And so in that case, the sponsor transaction route, you would just sign some sort of auth message and you would send it to a sponsor, and the sponsor would check to see, is this a valid message? Does this user have enough balance to pay me, etc.? And then they'll decide to accept or reject. And if they accept, then they will wrap your auth message in a transaction and submit it to the invoker. Then once the transaction has reached the invoker will decode this auth message, and it will give the portions to the auth opcode, and the auth opcode will recover the address, and it will set the context variable as the authorized address. And then the invoker will continue to parse each action that the user requested to do and auth call out to the targets as that user. And so each of the user's targets will see the message.sender come in as that EOA's address. And so that will loop through, as many times, as many actions as that user requested to do. And at the end of that, it will, if it was a sponsor transaction, it could transfer the payment to the token. And after that, it returns, and it's the end of the transaction. And so this is sort of an example of how you could have this interaction with an invoker. But the cool thing about EIP-3074 is it's not specifying exactly how these things happen. These are just a demonstration of how it might be implemented, but you could have it so you transfer the payment at the beginning of the transaction, and then at the end, you just refund the amount of the remaining amount of gas that wasn't spent. Or you could have something that says, I want to approve this token, and you may not even have to commit necessarily to approving. It's just implied by the function you're calling in the invoker. And so it creates a lot of ability for people to be creative and actually innovate without having to worry about going through the EIP process and hard forks and things. And so I think that having that permissionless innovation is going to be really helpful to see how we can improve the UX on leaps and bounds, even beyond the problems that I mentioned at the beginning. So I went through all of the amazing, cool things about 3074. There are significant downfalls that are concerning. And we think that even with these pitfalls, that 3074 is incredibly valuable. But it's important to mention that there are concerns. And one of the biggest concerns that we think can be resolved relatively easily is that it's possible to create a malicious invoker that steals all of the user's funds. Then the way that might happen is that if wallets allow anyone to sign 3074 auth messages without care or reason for which invoker it goes to, you could have some run-of-the-mill, like latest and greatest token launch, say you need to sign this message and then you'll be at the front of the queue or whatever. And if that happens, then once you sign that transaction, if you sign over that bad invoker's address, it could go ahead and it could maliciously create a bunch of auth calls based on the signature that may or may not have any relevance to what it's doing, and it can auth call out and send all of your tokens to some other address. And so that's why we've talked with many wallets and they are on board with this. And the idea is that you would have a whitelist in your wallet that says these are invokers the community trusts, and you can only sign 3074 transactions to these invokers. And this is a little bit similar to how signing actually happens in wallets today. Generally, you don't want to allow users to sign anything because you might have a malicious dApp try and say that you're going to sign some 712 message that says, I am authorizing use of this application, but it's actually a transaction, and that transaction sends your ether to them. And so generally you need to be protective of what you're signing. So that's a concern, but I think it's manageable. The other thing is that we can't spend ether in EOAs. And so there's a lot of good reasons. I won't go into too much detail about why that is, but generally you can't deduct balance from an EOA in the middle of the transaction. This will break invariance in the mempool and potentially open the door for denial of service attacks. We think that there might be ways of doing that at great cost, maybe 30 to 50,000 gas to do something like that. But in this initial version of 3074, it's not possible. Self-sponsoring breaks a weak form of flash loan protection. If you're a big smart contract developer, you might know that some people try and do this check where they say, require that message.sender equals tx.origin. And that way they know that this call has not come from a flash loan or something that's facilitating a flash loan. And that is a concern. And that is something that we're looking at audits right now to see how big of a concern is this. It's a very weak form of flash loan protection because if you look at what the miner can do, the miner can order flash loans across multiple transactions if they have enough capital. So it's not a strong protection. The last really concerning thing is that invokers could make upgrading Ethereum more challenging. If you have old invokers that people may not use anymore that potentially rely on some weird aspect of the EVM, if you upgrade and change that aspect of the EVM, and it might open the door for exploits on the invoker, now anyone who used the invoker in the past could be susceptible to being exploited. And this is a concern for 3074, but also a concern for a lot of things that are being built on Ethereum right now. Things that are expected to last for decades, anything that's expected to last for decades that rely on specific things of the EVM, they are going to make upgrading Ethereum more challenging. I think Optimism is going to be an interesting example to see because they rely on many specific things about the EVM. So upgrading the EVM, we have to take into account how things like Optimism are utilizing it. So those are the pitfalls, the UX problems that we talked about at the beginning. I think these are sort of all solved. You don't need a separate transaction for token approvals. You just sign a message that says do those two things, and the auth calls will take care of it. That's the same in the generalized case where you have one transaction that does n actions. If you lose your keys, you can preemptively say something like, if my account has no activity for 1 year, then allow this account to take over. Or you can do social recovery schemes that say, I trust these 10 people, and these 10 people could send transactions on my behalf if they work together. And if you want to perform actions without Ether, of course, you could do the sponsored transaction route. That's really the thing that motivated EIP-3074 in the beginning. So this is my last slide. Where EIP-3074 is today, we're targeting the next hard fork after London, which is Shanghai. The current thinking is it will happen in October, but these are things that still need to be agreed upon in the all-court devs calls. It's sort of pending on the outcome of these two audits that we have, which are going reasonably well. But this is a really big change, and it is going to open up interesting new things that could happen to users. And so we want to make sure that's as safe as we can. We're working to find people to write these invokers. This is obviously a difficult task because writing invoker is almost like writing a smart contract wallet, and there's not a lot of people who are doing that. And we're looking at funding for people who want to do that and for doing audits on those things, because these are going to be really expensive efforts. The last thing is that we've got a testnet running. It's the Pushy testnet, and the information is here on our GitHub if you want to join and try and write the invokers and play around with it. All the information is there. Any questions? That's like a lot of stuff.
Amazing. Thank you, Matt. That was a really interesting talk, and yeah, really excited to see all the innovations, I guess, that 3074 brings. Antoine had a question. Antoine, I don't know if you want to ask yourself or
Sure. Well, Matt, so is that going to require you to redeploy your contract? I'm guessing yes. Do you imagine people would redeploy, or would it be possible for them to
do you mean Are you saying the goal of this is to not have to redeploy anything? The goal of this is that immediately as this hard fork launches, every EOA is going to be able to utilize this, and they can begin batching transactions, and no one has to support it. This is the idea behind not doing the meta transaction route, where you would have to redeploy to support meta transactions.
Okay, yeah. I asked earlier in your presentation, it felt like maybe I had to. Okay, that's great. That's a huge improvement.
I have a question.
Go ahead, Weathercam.
So in like the meta transaction world, generally the people who will be running like I forgot the terminology, but like the relayers, I guess, are generally like people who are like the I guess the company or somebody who's like running the dApp, right? Who do you envision being like these invokers in the 3074 world?
So there's two worlds that we see the invoker sort of go, or kind of three worlds. The first world is wallets might just say, MetaMask might say, this is going to be so much better than what exists. And if we can be the first one to write a safe invoker, then this is going to be amazing. It's going to give us a head start. The thing is that it's a smart contract. And so generally anybody could use it. And so as soon as MetaMask does it, maybe Rainbow Wallet can adopt. That's what we don't necessarily want to do. What we'd really like to have happen is we would like, for the first time, this is truly like a community good, a public good contract. And so we're trying to have it be built in the open with open source, with governance protocols helping to fund these sorts of things. And so that would be the ideal world, is to say, there's only 3 to 5 invoker contracts in the world, and these governance protocols help to build them and fund them and audit them, and Open Zeppelin helped do some things, or whatever. And then everybody can just use them. All the wallets can use them. There's standards for interacting with them and stuff. And so that's the ideal world. And the third world is that, you just sort of have one-offs being built for sort of every application. And I think that's unlikely because the cost of developing an invoker will be so high. It's like similar to the reason, like, why are there not thousands of smart contract wallets? It's really, really expensive to build them safely. And I think that's what we're going to see with invokers.
I mean, I'm not talking about who's going to be building them, but like the people who are going to be running them, because like the invokers are going to be the people who end up paying for the gas fees and everything.
Oh,
right?
You're talking about the sponsors. So the invoker is a smart contract.
Yeah. Right.
Okay,
right,
so
sorry, yeah.
So the people who are going to be the sponsors are, there's a lot of different ways of going about this. And it's like, there's like kind of 2 main classes. There's like the centralized providers, or I guess 3 classes. There's the dApps. If you're a dApp, you might want to try and relay your transactions. Generally, that was more common with meta transactions because the meta transactions require that the dApp support them. And so it made sense. If you had to support it, you might as well have like your own custom integration for a relayer. What's more likely with EIP-3074 transactions is that your wallets will sponsor them. And so MetaMask will likely have some sort of sponsoring mechanism, or Rainbow Wallet will have some sponsoring mechanism. And that will be, not a lot, probably not a huge engineering effort for them to just send their users transactions and take, whatever cut out of that. And then the third is something like Gas Station Network, having a more decentralized way of submitting a transaction to this like network and having them decide who's going to submit it. And that's like obviously the ideal world. We want to get to that point, but in the beginning, it's likely that the wallets will, shepherd the transactions on chain.
Maybe I just have one maybe silly question, but is there not a world where a dApp is sponsoring the invoker for their own users and only their users? Like, I understand that's not an ideal world, but is that a possibility?
It's definitely a possibility. It's definitely a possibility if you're willing to pay, if you're trying to pay for the gas or subsidize the gas costs, that's definitely when that would happen.
Because even if you're not building your own invoker, you're just deploying your own.
Yeah. So that's a good point. If you're a dApp and you're trying to, focus on onboarding users, I don't know if that's so much as a thing these days with gas prices the way they are. But yeah, if you're just trying to like help get people onto your platform, you would definitely do that. If you're not thinking in those terms, you're just thinking like, this is a service and I will pay fair market value, then I don't really see a value of being a dApp to do that, other than, I think that would fall into the wallet's hands more.
And then one last question, you did mention governance and stuff like that, similarly to GSN. Do you have stuff written about that? I'm just curious how you imagine that working.
Governance as in?
As in how these 3 or 4 or 5, whatever, kind of public good invokers could be governed.
This is a really challenging question. That's also something that rollups are tackling at the moment. If you think about how like a lot of these rollups are, they're always going to have to be upgrading to keep up to date with what's happening with Ethereum, especially Optimism. Optimism is going to have to upgrade with mainnet upgrades. And so invokers could go a similar route. Like if they can find a good solution that's decentralized to, upgrade, the invokers could have a similar mechanism that says, like, let's just redeploy at this address or proxy or whatever. And as long as this group that was somehow created agree, then we'll upgrade it. I was talking more about governance in the sense that we would really like to have these, these DeFi protocols with these massive governance treasuries help fund something that significantly improves the core protocol but also themselves. Like I did some analysis on how much do people spend on ERC20 token approvals. And in March to mid-April, they spent like $25 million on ERC20 token approvals, and Uniswap users were using something like $15 million of token approvals. And so 3074 will save at least 30% on that, if not, much greater. So that's $1 million a month that these DeFi projects would save.
Awesome. Thanks for your talk, man.
Yeah, definitely. Thanks a lot for having me. I appreciate getting a chance to talk about 3074.
Yeah, I really appreciate it. Ryan, did you raise your hands there, or were you just about to ask a question, or?
No, I was mostly exclaiming at how cool this is, but I did have one idea that I wanted to ask. Not that it probably has any real world answer, but since you have been looking at what DeFi projects might benefit from this in terms of like cost savings or incentives for why their treasuries might want to be involved in the sponsorship of these invokers. If this were to roll out, and like, I mean, I know the target is October, but if this were to roll out tomorrow, what would you expect? Like would it be like LP pools that get the most involved? Would it just be like typical tokens? Like what would be the first major change you would expect in like the DeFi ecosystem to have to be?
Yeah, I mean, if this rolled out tomorrow, everybody would be scrambling to figure out how to write an invoker. And that's concerning. I mean, that's great, but it's also concerning because an invoker is not something you would want to scramble to write, because this is truly a test of, we have to write code that is safe. A lot of times it's okay to have an upgradable mechanism. I saw that ENS just removed their ability to upgrade the ENS, the .eth domain. And so it took them 2 years to be comfortable to do that. And so, a lot of people are okay with having those rails where they have this like hatch, this trapdoor hatch to fix things. In invokers, it's quite a bit different. It's very concerning to have that sort of the trapdoor, because in your ecosystem, your DeFi ecosystem, if you think about like Uniswap, you can conceptualize everything that is in Uniswap, and you can say, this is the total value locked in Uniswap, and this is the worst thing that the Uniswap governance people could do if they changed the contract and ran away with your money. But with a 3074 invoker, because there's nothing at the consensus layer that's enforcing that what you committed to is what is happening, what is actually happening on chain. If someone upgraded the invoker in a bad way, you could steal every single person's funds who interacted with that invoker. And so that's why it's something that really needs to be truly permissionless. Like it is a concerning thing. And it's, when we first came up with this idea, it was a lot like, we're handing every developer a gun and they're got it all aimed at their foot, and we're just telling them exactly how to not shoot themselves. And it's just a matter of them not shooting themselves. Like it's such a powerful weapon, but it has to be wielded correctly.
So how many months before we get a really big broken foot?
I mean, we're trying to, the lead time is significant to build something that's really safe. And so that's why we're starting the PR meme campaign now to try and find people develop. And, we talked with Trail of Bits, and I think that there are people who would be interested in helping audit something like this. And so it's just going to take a long time and a lot of people being involved to do it right.
All right. Well, Matt, again, thank you so much. This was very, very interesting. Appreciate it.
Thanks a lot for having me.
Back on at some point.
Yeah, sounds good.